Hey yo, what's up guys? Baby Bear 4812 coming at you one more time today with partition labels problem 763 because Amazon has gone trigger happy on this one in the past 0 to 6 months. It's not too difficult of a problem, but it's a good one nonetheless, so I figured we could cover it and get to the bottom of it. As always, if you haven't tried it yet, pause the video, give it a shot, then come on right back. But for those of you who have tried it, sorry, let's jump into it. We're given a string S consisting of lowercase English letters, and we want to partition this string into as many parts as possible, so that each letter appears in at most one part. Okay, so right here, we want to split it into as many parts as possible, such that each letter appears in at most one part, and we want to return a list of integers representing the size of these parts. All right, so if this is our string, and I'll zoom in here a bit. If this is our string, so this whole big long mess, that's what is that, like 24 characters long. The partition would be the output that we would give is 978, representing the first 9 characters of the string, which I think would be up to here. That would be one partition. Okay, as you can see right here. The next one would be 7 characters long. That would go up to here. And then the third one is 8 characters long, which covers the rest of it. The reason we split it up that way is because in each of these, as you can see in partition 1, we can see letters A, B, and C, but we cannot see A, B, and C in any other partition. D, E, F, and G we can see in this partition, but not in the others, and H, I, J, K, L for this final one. We are told that another possible combination is this one and this one, where each of them does have their own unique set of characters that doesn't exist in the other partition. Though it's not the answer we're looking for because it splits S into less parts than is possible. We can see here that it's possible to split it into 3 parts and not 2. So 3 is the output that we wanna put out, and the output we want to output. And this is the format we want to do it in is by putting in the value, sorry, not the values, but the lengths of each partition. We're told that S will have a length in the range of 1 to 500, so we don't need to error check for an empty input, and that it consists only of lowercase English letters. Cool. So let's think about this one for a moment. Again, if you're seeing this for the first time, I'd suggest you kind of scratch your head over it for a bit before jumping into the solution. But let's have a look at what we're working with. So I've copied down the same example that we were given, the same 24 characters, and I figured that just a few minutes of walkthrough should be able to get us to where we want to be. When I kind of saw this problem, I thought about it this way. My first character that I see here is an A. If I'm looking at an A here, this partition will be as long. How do I put this? This partition at the very least will end at the final occurrence of an A. So if my first letter here is an A, and I need to make sure that in this partition all the A's are in it, if my last character here, for instance, was an A, well, by necessity, this whole thing would be one check. I would only have one partition. That's not the case though. If I was to do a walkthrough through the string, I could actually see that my final A is right over here. So that means that if I start with A and I end with an A, at the very least, this will have to be my partition at the very least. Okay? So the question becomes, first off, how do I determine where my final A is? Well, if I'm doing one walkthrough and I'm starting right here, and I kind of walk along, I don't know when my final A is. Maybe, I'll see an A here, but then what's to stop me from going further and saying, okay, well, maybe there's another A all the way over here. And so that, with that kind of, with that, that's not really a conundrum, but that really drives the necessity, I guess I should say, for us to do at least one walkthrough cleanly where we're going to determine for every character what is the final occurrence of that character. So step number 1 will be to actually set up, use some data structure that will be able to tell us for every character I see what's the final occurrence of this thing. So if I come across an A, I need to know where my final A is in order to acknowledge that I need at least a partition of this size. So if you haven't guessed it already, I'll let the cat out of the bag and say that the best data structure to do this would be a dictionary. And what we could do with this dictionary in one walkthrough would be to say, let me walk through, and every time I see a character, I'm going to update its value in the dictionary, update it to the index that it falls in within the string. So we would take something like, we'd have a format that takes the character, and then the final index that it occurs in. This is going to be a very simple piece of code, and that will do one linear walkthrough where we're just going to append these values. And so our step number one will be something like, I'm going to write make dictionary, just dict, just a bit of shorthand. But I think that first step makes sense. And again, the reason is because if I now start walking through and want to think about, well, if all of this character that I'm at, all of the A's need to fall into one partition, I need to know when the final one is. That will give me some idea on when to have like a start and ending index. And that kind of guides me nicely into my second point, which is when we're beginning, and as I'm walking through this, I now need to think about where is my partition going to begin and end. So I think it kind of makes sense to say, look, my first partition will always start here, and we'll call that S. And let's say for now, after I've taken my first step here, I realize that, okay, the first letter in my partition is an A. The last time an A occurs is right here, so this would be at index 0, 1, 2, 3, 4, 5, 6, 7, 8. Last time I see an A is at index 8, so at the very least, I'm going to need a partition from 0 to 8, which would be of length 9. Now, how do we determine if this partition is actually going to cut it? Does it actually follow the rules? Well, we'll do the following. I'm going to keep walking through this string one letter at a time now, okay? I'll have, and maybe you know what I could do is I can say maybe, keep a mock dictionary here, and I'll say, so A, we found it ends at an 8. So every time I'm walking through this, first my entry would be A0, then I'd see A2, then I'd see A3, 4, 5, 6, and then I'd see A8. And the final time that I'm updating it would be that last occurrence of the 8. Cool. I now go to a B, and pretending that I've done my first walkthrough, I realize that a B ends with 1, 3, 5. So index 5 is the last time we see a B. Okay. I'm walking through here, and I check my index. I say, okay, I'm at index 1, and I'm looking at this character, and this character is B. When does the final B occur? Okay, the final B occurs at the index 5. Does that mean that our current partition as it stands right now is okay? Well, yeah, it does, because I've seen an A, and I know my interval covers all the A's. I've seen a B, and I see that my partition covers all the B's as well, because B ends at 5, which is before 8. So I've got all the A's, I've got all the B's. I'm looking good so far. A, okay, we already know that's in there. B, again, same thing. Now I look at the C. I come across the C, and I have to ask myself, I have a C right here. My partition is from 0 to 8. Do all of the C's fall between 0 and 8? Well, let's ask ourselves. After, had we done our first walkthrough, we see 0, 1, 2, 3, 4, 5, 6, 7. Index 7 is the last time we see a C. So the answer is yes. All of the C's are contained within this interval. We see B again, A, C. We already know these are good. A is good. Okay, cool. Now, I'm sitting at this index right here, and I realize that as I'm walking through this thing, I've reached the end of this interval, and I have not had an issue. So everything I've seen here has been in this interval. That's awesome. So what we're going to do is append the length of this interval, which in our case is 9. I'm now completed with this interval. This is all done. We're happy, okay? Let me scratch these out. So we have one partition locked and loaded. It's now time to start another partition. This second partition will start at the D, okay? So I'll start here, and it will go, we don't know how long. We can start by saying it'll go to here until the final occurrence of a D. And again, let me make this a bit more clear. Right over here. And again, I'm not going to use indices here. You can assume that we've already done a walkthrough and created this dictionary. But I've got a start and an end here, okay? And I'm walking through my dictionary, and I notice, oh, wait, okay, so D is in here. It's in my interval. All the D's are in this interval. Now I see an E. But I notice, wait, my final E is actually outside of my interval. That means my interval is not big enough. So I've got to extend my interval now over here and then walk on through. Since this E, the final occurrence of an E, fell outside of our current interval, we need to extend our current interval in order to house it. And by taking this greedy approach all the way through, and you can kind of continue, and I think at this point the illustration makes sense. At this point we can kind of walk through and notice that, okay, if I'm in an interval and I notice that this interval contains a character, and the final occurrence of that character is outside the interval, in that case I need to expand my interval and make sure that we contain it. And so if we continue that, we'd get a 7 here, and then this final one would be these 8 characters over here, and we'd get an 8. And that's really all that it takes to solve this question. So the first step was actually making the dictionary, And then the second will be, I'm going to just very loosely say here, like set intervals. I know that's not very descriptive because it's like, well, that's the purpose of the question. But the code will make it a bit more clear. I hope that this illustration did make sense. So the walkthrough, I think it's pretty straightforward. This isn't too abstract of a question. I don't think it's too difficult to grasp, but let me know in the comments down below if you disagree, and I'm happy to elaborate or clarify if there's anything here that doesn't make sense. And with that, let's dive into the code and make sure we can hammer this thing out. So as I mentioned, typically we would do some sort of error checking, but we're told here that we will be given a legitimate number. So we'll skip that this time around. And then our first step was to actually make the dictionary. And then we said kind of set intervals or find the intervals, and then we'll return our final answer. So return answer, return result. I always like to call it result. So we're gonna make this dictionary, and I'll call this dictionary something like last occurrence. Okay, final occurrence. You can call it whatever you want, even something like D. But I'm just going to be a bit descriptive here so the code makes sense. I'm then going to walk through this string here, and what I'll do is I'll put that in a for loop, and I'll say for I representing the index and C representing the character in enumerate S. So for those of you unfamiliar with it, this enumerate function is really handy, and it allows us to walk through an iterable. So we can do it with string, we can do it with an array as well. And you've probably seen me do it with the list as well. And at every step along the way, I'll have access to both the index and the actual value in there at the same time. So it's pretty handy. The reason I'm going to do this is I'm just going to say we'll take the last occurrence dictionary at a character C. So we'll have, again, that character, and then the index that we saw it at, and that's going to equal I. If we are overriding this, so in this case we see, like I kind of mentioned originally, if we were to do this, we'd have A originally would have been 0, and then we would have seen another one at 2, and then we would have seen another one at 6, and another one at 8, and we'll keep overriding it until we've seen the last one, and that's how we know that's going to be the last occurrence. Because somebody may point this out, and just for sake of completion, we can also do the equivalent of list comprehension for dictionaries within Python. So we could also have said something like last occurrence is equal to, and now let me make sure I get this right, it would be like character and index for index and character in enumerate S. So we could technically put this whole thing in one line. I like to leave it like this, not just in interviews, but also when I'm making these videos, so that it really goes down to the kind of first principles and makes it as understandable as possible. But I did want to throw it out there that is an option. All right, so now the meat here. We're going to need some sort of result, and at the end of the day, we will return our result. And now we actually want to do this walkthrough. So two things we said we needed. One was going to be a start, and one was going to be an end of a current interval we're looking at. I'm going to set the end to none for now, just for a second. And the reason I'm doing that is because I just want to walk through the entire array. I don't want to have defined it just yet. And we'll basically say if there is no end right now, we will set it based on the first character that we see. So with that in mind, we'll actually start the same way as we did here. We'll say for every index and character in enumerate S, I'll say the following. If end is none, we want to begin by saying, let me set the end to the last occurrence of the character that we've come across. So we'll say end is equal to last occurrence of C. Okay, so we've now set the end. Now, at any given point, one of two things can happen. Either one, I've reached the end of my interval and I've said, okay, cool, like I got to where I needed to be. Let me append this into my result, and that kind of happened here when we reached this A. We said, oh, okay, like I've made it to the end of my interval, which means we're good. This interval is done. I'm going to start a new one now. In order to check that condition, I'm going to say if I is equal to end, then we're going to want to say result.append, and we want to append the length of this interval. If this interval starts at start and ends at end, then we're going to want to append end minus start plus 1. Okay, this plus 1, I know some of you may know, but I always see a bit of confusion. If you've got, think about indices, if we've got the indices 0, when we're doing 0, 1, and 2, if I tell you this is index 0, this is index 2, and we want to find the length here, it would be 2, this is 0, 2 minus 0 is 2, but since both those are inclusive, we need to add the 1 because there are a total of 3 items in there, okay? So that's why we're doing the end minus start plus 1. We're also going to want to say, I want to start a new interval now. My new interval is going to start at wherever my end was, and I'll add 1 onto that. So if we ended right here, my next start is going to be 1 level over, or 1 step over, and we don't know our end yet, so we're going to say none. And then when we do this kind of iteration, we'll get back into this business over here. Otherwise, if we haven't reached the end, so if we haven't reached the end, and I'm looking at a character that, so let me put it this way. When we looked at this B, we said, no, we're good with B. The reason we were okay with B was because it ended, its last occurrence was within our current interval. So that wasn't a problem. But when we landed on the E here, we said that since, our original interval here only went this far, okay? When we landed on the E, we said, oh, damn, our final occurrence of E lands outside of my current parameters. I need to extend or expand my current parameters. And that's what that's the situation I'm gonna have to account for here. So if last occurrence of the character we're looking at is greater than the end, then we'll say that end is equal to last occurrence of C. And that's going to extend the interval as much as we need to. It is worth mentioning we can never shrink an interval. So if I've set an interval here at A, so we start at A and then we need to go at least until the last occurrence of A, there's nothing that can happen in here that'll tell me, oh, let me bring the interval in backwards. If it did, then that's going to kick out one of the preceding characters that we've seen so far, and our interval will no longer include that preceding character's final occurrence. So I hope that makes sense. That's why I'm not checking for whether or not this B, for instance, falls within the kind of the realm or not, because I'm only concerned if it falls outside of our current parameters. And so in case I've missed anything obvious, this actually should be it. I'm going to give this a quick submit. Make sure that I haven't messed anything up. Awesome. And you can see here the runtime is very favorable and the memory usage is very favorable. Slurring my words, very favorable. The reason for that is this. Our runtime is O of n. We're doing one walkthrough here, O of 2n, which simplifies to O of n. We're doing one walkthrough here to actually create this dictionary, and we're doing a second walkthrough to check these intervals. The space complexity is in fact O of 1. The reason it's O of 1 is because we have only lowercase English letters. There are 26 letters in the English alphabet, meaning that our dictionary can only at any given point have a maximum of 26 entries. That's O of 26, which simplifies to basically O of 1. Meaning if even I had a string that was 1,000,000 characters long, at any given point, no matter how much n increases, we can have at most 26 entries of the space that we're going to take up. So this is O of n time, O of 1 space. I hope this explanation made sense. Again, as you saw, it's a very popular problem with Amazon, and I know that when you guys face it in your interview, you're going to crush it. I'll see you guys next time. Peace.